Good afternoon, all. Haseebuddin sir, you can hear me? Dr. Haseebuddin, can you hear me?
Am I audible?
Yes, sir, you are audible. Sir, can you be a little bit louder? Your voice is really low.
Am I audible now?
Yeah, sir, now it's clear, sir.
Yeah.
Okay, sir. We will just start now, sir. Very good afternoon, all, and I welcome you to today's last session on the faculty development program on applications of 3D printing technology in engineering education, sponsored by AICTE Training and Learning Academy, jointly organized with Department of Mechanical Engineering, Danan Sagar College of Engineering. So in our today's last session with us, we have Dr. Haseebuddin M R, who is our in-house faculty. Sir, I heartily welcome you to the faculty development program on behalf of the department.
Yeah. Thank you, Anbadiga.
Before I start with the session, I'd like to introduce the speaker with each one of you. Dr. Haseebuddin M R is currently working as Associate Professor in the Department of Mechanical Engineering, BSc, Bangalore, and he has an experience of over 13 years in academia. He also holds the post of Deputy Controller of Examination in DSE. Dr. Haseebuddin M R has PhD in the area of Advanced Material and Processing from VTU Belagavi. He is specialized in production engineering and system technology. His area of research interest is nanomaterial processing and Six Sigma. He is the member of Institute of Indian Foundrymen. He has published research papers in peer-reviewed journals. His papers have won Best Paper Award in couple of international conferences. He is reviewer for many journals of repute. Dr. Haseebuddin has also organized and coordinated number of workshops, conferences, and FDPs. He has also worked on research projects funded by KSCST, IEDC, Department of Science and Technology, and AICTE. He is currently working on project titled Development and Characterization of Bamboo Fiber Polymer Composite for Structural Application, funded by AICTE under Research Promotion Scheme. He holds various positions, and his few of the roles include Deputy Controller of Examination, DSE Autonomous 2015 to till date, Member Academic Council DSE, Member Board of Studies, Member Board of Examination, Member Anti-Malpractice Committee, Member Department Academia Audit Committee, and Research Coordinator R&D Center, Department of Mechanical Engineering. Sir, it's our immense pleasure that you are with us today, and I would like to hand over to you now to start the session.
Thank you, Professor Badigar. I hope I am audible, and I think my screen is visible.
Yes, sir.
Yeah. I thank the Department of Mechanical Engineering for giving me an opportunity, and also thank the AICTE for funding this FDP. The topic for my presentation is application of 3D printing technology in. I am speaking on the topic pedagogical applications of 3D printing. Warm good afternoon to all the participants, and once again I will introduce myself. My name is Dr. Haseebuddin M R, Associate Professor in the Department of Mechanical Engineering, Danan Sagar College of Engineering. I will start with the term pedagogy. The term pedagogy is usually associated with teaching, and we can call it as the theory and practice of learning. Pedagogy in general deals with how the process influences and is influenced by the social and psychological development of students. When we speak of pedagogy as an academic discipline, in the study, we can say it is a study of how knowledge and skills are communicated to and educational context, the interactions that happen, and how the learning are taken into consideration. Both the theory and practice of pedagogy vary greatly as they reflect different social, political, and cultural contexts. So coming to 3D printing, the 3D printing, we can say it is a process where an object is manufactured layer by layer from 3D CAD data. 3D printing is a relatively new industrial manufacturing method and is on the verge of becoming recognized as one of the elementary manufacturing methods. And in order to make this happen, methodology for including 3D printing in engineering education must be developed. There are technological developments happening in additive manufacturing at a very faster rate compared to development of additive manufacturing education. So educational institutions and universities need efficient and organized methods in order to produce engineers who can work on additive manufacturing as per the requirement of the industry. So coming to, just a minute.
Sir.
Yeah. Just a
Okay.
minute.
Okay, sir.
You can see the slides.
Yes, sir. It's visible. Please put it in presentation mode, sir.
I think the camera is off.
Yes, sir. Camera is off.
We have to look at the factors related to learning and developing pedagogical arrangements in additive manufacturing. So there, we can say there are mainly three factors related to the learning of 3D printing and to develop pedagogical and practical arrangements in order to implement 3D printing education based on industry needs. So looking into the first factor. So we need to create an informational background for learning and connect the traditional engineering education principles to it. And also creating pedagogical background and practical arrangement for 3D printing education in engineering education. And the third factor is we need to create novel learning outcomes for learning 3D printing based on industry needs. So one question that need to be addressed by universities is there is a lack of pedagogical solutions for additive manufacturing education. So there is a need to have a proper arrangement, that is, we can say a pedagogical arrangement for 3D printing education. The need for additive manufacturing expertise in industries is increasing for wider applications of 3D printing in the operations in the industry. So this will present a societal need as the increase of use of 3D printing presents the possibility of improving viability and competitiveness in industry. So there are some questions that need to be addressed by universities and institutions providing higher education. So some questions that can be addressed in engineering colleges to bring in the culture of 3D printing education is the first thing is how 3D printing can be combined with traditional engineering education. And this will create a view into combining additive manufacturing into traditional engineering education. And it will help to understand the necessary factors that are associated with it. The factors are related to learning of traditional engineering design and additive manufacturing and the research that is generated and needed to implement AM in engineering education. The second question that universities should address is what kind of pedagogical and practical solution does 3D printing education require? So this will help fill the gap. That is, there is a lot of gap between that is in literature that is published on the need of 3D printing education and what exactly the position is. So that is the lack of pedagogical solutions for AM education. In addition, it generates solutions for the practical arrangement of additive manufacturing education. And the third question that universities may address is how does the learning of 3D printing work with multiple technologies? So this will help in collecting feedback from that is engineering students and other stakeholders regarding learning and use of multiple additive manufacturing technologies. The arrangement of the learning is based on learning outcomes, which can be drafted based on the need of the industry. So first thing we need to take care is the creating of a learning environment. So if you look at the slides, there is a engineering design learning environment that is associated with a student. So the creation of learning environment is based on the studies conducted at mechanical engineering degree program at a university in Finland. So one of the key factors in this study was how the traditional engineering design, which combines several course contents, can be put into practice. So engineering design forms one way for the students to practice their skills in that is the practical situations by performing different customer projects. This is used as a starting point. That is in a university, that is a university in Finland. There was a study conducted, and the principles of engineering design environment were presented. You can see in the figure how the creation of new engineering environment, that is how necessary factors were recognized and developed to function in the environment. The new environment contains possibility it may be allowed to handle and solve problems, perform design tasks through various development works, and use 3D printing equipment as a practical method, and use that is skills and experience. The structure of the created learning environment consists of the factors such as that is a description of the active learning in the environment, and simplifying the 3D printing process chart, how new models for AM design process can be developed, learning the assignment process charts, and learning environment future development purposes. So first, this will start with creating a learning environment, and having a active learning 3D printing practice also is required. So here you can see there is active learning in 3D printing. So it will take care of the modern engineering education uses more participatory. So example, I will just give an example later on. There are various pedagogies involved in this. This model is an active learning method, and this was used to develop the learning environment, and it gives perspective that the important factors are learning that are involved. So the model of active learning consists of 6 different factors as shown in figure. So as shown in figure, there you can see the background knowledge is required, the knowledge provided by the mechanical engineering degree studies, and the basics of DFAM, and the practical exercises, that is the practical laboratory exercises with 3D printers. That is also sometimes they need some guidance. Students need some guidance. Partial guidance is required, and partially fully independent work, and the students can perform their own projects and learn more. And also the students will require supporting lectures as well. So supporting lectures it will help, that is we can say introduction lectures, that is giving some basics of the 3D printing technology to the students. And always tutoring is an important part. Without tutoring, it is very difficult. A teacher works as a tutor during the printing and gives guidance and support. And also the students need to be given information about the equipment, that is what is some knowledge about the printers, and especially the safety guidelines in printing has to be communicated very clearly to the students. And one more important thing is that is the planning. Planning is a very important part of this, that is because it concerns with the independent work. The student must plan his or her own time usage between theoretical and practical learning. This model requires unprompted work from the students with the help of the tutors. So there is a research study that was conducted by Pickering et al. So according to him, he has created a learning assignment model. So there are various assignment models that may be available. If you look at the literature, various universities who have already implemented 3D printing in engineering education, they have their own methods and models. So this is one of the assignment models that was adopted by Pickering. So by assigning tasks to students, the additive manufacturing product design process can be introduced, and the task can be divided into various sections as shown in the model here. So it consists of various aspects like recognizing the need and drafting the idea for the part, and what is the need that comes from the student side, that also has to be addressed, and designing and modeling of the part using 3D model softwares and scanning, that also has to be taken care, and orientation lectures about the printers, and the basics of printing has to be communicated, working and safety issues, printer setup and printing processing, post processing, inspection of the parts that are printed, and result evaluation and recognizing the possible need for iteration, and also presenting the results to the faculty. And also iteration, sometimes in the iteration process, the models has to be reprinted, redesigned and reprinted. So that also has to be included in the model. And the final review of the part and conclusion. Also, there has to be some feedback mechanism by which the faculty can collect the student feedback, and the student also can record their views about it. So this is one of the models that is being used in one of the university in Finland. And coming to the future of learning environment. So here the future of learning environment requires continuous development, as in most of the environments which leans on technology. Here the state of technology is in the center, and the environment requires the acquisition of other additive manufacturing technologies in the future, such as SLA, and material jetting, and SLS. These are some of them that I can mention. And the learning assignments created for the study are the first step, and the feedback which will be that generated from the students can be used for further development of the learning assignments. So the learning environments that is it is meant to be used as versatile as possible, and one development path can be used in a prototyping environment as shown in figure. So this is as per the studies at university. And there is some strategies that can be adopted by industry, that is to equip student with industry requirement. That is educational organizations, education institutions has to look into this. So what is required is organizing practical 3D printing learning. That is the environment has to be created, and the implementation of additive manufacturing into the curriculum of engineering degree programs. So to make this happen, this can be done by organizing practical sessions on additive manufacturing learning environments, and the identification of learning based on 3D printing and is pedagogical development. Also, since we can say that since 3D printing learning is inversely related to the additive manufacturing requirements, which can be connected to the experience level of the students. The basic nature of engineering must be connected to additive manufacturing principles by identifying the need for pedagogical development. If you look at the traditional pedagogies, we need to upgrade the traditional pedagogies and the perspective on the implementation of additive manufacturing in engineering education. The 3D printing is relatively new technology, and the traditional pedagogies are not fully suitable for its implementation. The there are many model pedagogies available. Some of them I have discussed, and there's many more that can be implemented based on the need of a particular institution or the need of a particular curriculum. I will just throw light on how the 3D printing and engineering courses can be linked. We are one of the first colleges in Karnataka, that is Dayanand Sagar College of Engineering, who has introduced 3D printing in engineering education. The first year computer-aided engineering drawing itself has been connected with the 3D printing lab. It can be done for most of the courses wherever some type of 3D printing can be included. This can be incorporated with the 3D printing education. And if you look at the models here, these are solid models that can be 3D printed. Most of the engineering education institutions have now done away with the traditional drafter and the drawing boards. So one problem that many engineering programs face is covering the POs. So most of the POs may not be covered in most of the courses. So 3D printing can be used to upgrade the curriculum and integrate with many courses. That is many POs such as modern tool usage, conducting investigation of complex problems, individual and teamwork can be covered by integrating 3D printing education with many of the courses. So what we have done is at Dayanand Sagar College of Engineering, the students, what they study in theory, they will print the parts in the laboratory. Ours is the first institution to include 3D printing for the first year students. So they will be studying the theory part in the theory sessions, as well as they will be printing the models in the laboratory. So I will just give some examples how successfully the 3D printing has been integrated with some of the courses. So the 3D printing lab for first year, that is what they do. They will first they draft, then they will make a model, to a scaled down model, and they will print the models in the lab. So this is how we have integrated the first year education with that is especially mechanical engineering sciences with and the computer engineering drawing with the 3D printing lab. And coming to, these are some of the models what students print in the first year: the cam follower, mechanism, pantograph. They will be they may be asked to work in teams. Students can form a team of 4 or 5. Each student can print a part and they can assemble it. So they will learn the basic mechanisms, as well as it will help them learn the mechanisms that is theoretically that are difficult to learn. Easily they can 3D print and they can make the mechanism, they can assemble them, and it will help them in a great way. And also coming to the second year, how we can integrate 3D, that is computer aided machine drawing. So the assembly parts can be anyway. They are most of the universities, they are using softwares. I don't see any institution using drafters nowadays. So the 3D printing can be integrated with the assembly drawings as well. Students can they can work in teams. They can model and they can make different parts and print it, and finally they can assemble the parts. These are some of the assemblies just I have shown for example. And coming to mini projects and projects, the students are given hands-on experience in the first year itself. They will be well equipped to use the 3D printers, and they can use the 3D printers for the mini projects as well as major projects. In our institution, most of the students working whenever they are required the facility, they can use it. Just I'm taking some case studies here how my students they have used 3D printing. This was a mini project. What you see, they had work on the aerodynamic drag reduction in bus model using CFD. So it was a major work during lockdown. Students had a lot of time. In this study, the effect of the passive flow device and the rare extension on the reduction of overall drag was investigated. And the actual bus model was designed, and the CFT analysis was performed on ANSYS Fluent to find the drag generated by the bus. So also here, boat tail is attached to the rear of the bus to reduce the pressure drag. So what we found, it considerably reduced the large recirculation zone in the wake at the rear end of the bus. But the problem, because we consider this as a major work, students were very eager to publish it in a reputed journal. So we tried to publish it in many journals. It was rejected because the lack of because of lack of validation. They cited the reason. So then we thought of that we'll work on this matter, and we made a scaled down model using 3D printing. And just a minute. The 3D printing, just a minute. So we created a scaled down model that is 1:2 ratio, and that is by 3D printing. And we did some more tests. That is, we thought of doing some experimental validation, and we conducted a smoke test in one of the laboratories in our college to check the streamlines around the base, and also the modified models were 3D printed and tested again. So we changed the dimension and the shape at the rear end, and with various iterations. As we have 3D printers, we should thank the institution. We were allowed to print the various models, and we tested for a period of time. Then we got very good results, and because we validated the paper is under a publication in a reputed journal. So this is one of the examples how the 3D printing, when the students are well versed with the printing concept, they can use the 3D printers. They can use it at various levels, and various courses can be integrated. Also, one more example is for major projects, our students, one of the batch, they're working on that is the design and development of an ornithopter. So again, because of various reasons, during last year, because of lockdown, we were unable to procure the components. So we thought of designing by ourselves. Students got into the lab. They printed all the gears, and all the mechanisms were 3D printed in the lab, and successfully they have assembled the component. And just a minute. This is one of the model ornithopter that was developed in our lab. Uh, that was the ornithopter that is well designed and developed by mechanical students at the Anna Sagar College of Engineering. And looking at the non-mechanical courses programs as well, most of the programs they have some type of models to be prepared. Civil engineering, architecture students, they spend hours and days together just to develop the models. As we have a program on architecture in our institution, I've seen how the students spend their times. Sometimes they work in teams, days together. Sometimes 10 o'clock, 11 o'clock in the evening. I've seen them sorting out, preparing models out of. They used various materials, cardboard, wood, and I had an interaction with the faculty at architecture. Why not introduce 3D printing for creating models? And they were very much satisfied because they had also done some type of study how some institutions abroad are using 3D printing for creating the models. So how it helps the architecture and civil students is in terms of money and as well as in terms of time saving. A lot of time can be saved, and very accurate models can be 3D printed. So this is how these are some of the models. For example, some institutions already they are using 3D printers for printing the models. These are some of the examples. So from the literature as well as the institutions that have already introduced 3D printing as courses in various levels, from that we can conclude that the learning environments required different process models, both from technological and pedagogical point of view, combined with 3D printing infrastructure. And the future development of 3D printing education requires development of additive manufacturing learning, and the environments should contain up-to-date additive manufacturing equipment and the possibility of the students to use them independently. And this requires sometimes institution has to the problem with institution is it comes to some type of investment. So if they have to introduce 3D printing generally at all departments, all levels, some type of investment will be required. So this requires a new kind of view of engineering education, where the traditional classroom lecturing can be replaced with versatile learning, while the students can be able to reflect, as well as they may research and analyze what they have learned through perceived learning. And if you look at the data collected from various organizations, that is institutions abroad, the graduated engineers possess sufficient additive manufacturing skills in order to export information that is required by the industries about the possibility of using additive manufacturing in the operations in the industry. So this requires some type of versatile 3D printing courses where the students can learn and experience 3D printing with multiple technologies simultaneously. And also this enables more advanced learning situations with additive manufacturing, enabling the students to develop into some type of expertise they can develop according to the need and requirement of the industry. Also, we can say that the 3D printing in education sector will definitely it will bring some type of understanding, and it will convert concepts into tangible form. And the engineering universities having 3D printers in their institutions can transform innovative ideas into reality. With some help from the faculty, they can build 3D labs in the institutions. So the need of the hour is introducing 3D printing in engineering education in the universities. It will bring some type of reform in the education, and not only making the students understand the concepts better, and they can use it for various purposes, for many projects, and for various purposes throughout their 4-year stay in engineering program. So that was a little bit of insight on how the 3D printing can be introduced in educational institutions. And I like to thank the AICTE for funding, for sponsoring this faculty development program. And also I thank the coordinator, Dr. R. Keshamurthy, who is HOD of Department of Mechanical Engineering, Dayananda Sagar College of Engineering, for giving me an opportunity to speak on the topic.
Thank you very much, Dr. Haseebuddin. Now, if any questions from the participants, they can please post it in the chat box, or else you can unmute yourself and go ahead with the questions. Any questions, you can please post it in the chat box. So in the meanwhile, participant asked the question, and myself have one question for you.
Yes.
Sir, as we all know that the 3D printing curriculum, whenever it is introduced, it is very beneficial. But as coming to job prospectus at the end, when they want to get in, the industry experience is very much essential. So is there any way through which we can tell to the industries that it is implemented here, or is there any way we can attract the industries towards the institution so that they can take up our students and train them in?
Yeah, if you look at the literature that is available in journals published, there is a lot of demand for 3D printing experts in industry. But the educational institutions are not providing that expertise. Again, the industries has to train them after the the student graduates and joins the industry. So there are some organizations or institutions that have already implemented 3D printing education. And coming to your question, it was focused on that is what industry is that is requiring. So once we introduce the 3D printing into curriculum, they can work on industry-related projects. The institutions can tie up with organizations that are into 3D printing, and they can work on the industrial projects. Also, consultancy can be brought in into educational institutions. By this way, the faculty as well as the students can have hands-on that is experience working on the industry related projects. So if there is some type of a memorandum of understanding with the organizations who are working on 3D printing, they can give some mini projects to students while the student is still in the college, and they will require some type of hand holding in the beginning. But in the end, if you look at the requirement that is there in the industry will be getting ready-made expert after the student graduates from the institution portals. So this way, both the industry as well as the student community, all both will be benefiting.
Yes, sir. Thank you for your answer. As you said, the MOU can also work it out and help. So any other questions from the participants, can please post it, or else you can.
If you look at some literature that is available, there is the demand for 3D printing, both especially in metal 3D printing. The industry is growing exponentially. In the next 4 or 5 years, thousands of jobs will be created in the field of 3D printing. There is definitely there is a requirement, and as per the requirement, there will be demand in the future. So institutions have to gear up now and start introducing the 3D printing education at the first year level itself. It can be used at most of the courses.
Thank you very much for answering that, sir. So I think we don't have any more questions from the participants. So I think we can wind up the session over here. Before we wind up, formally, I would like to thank you for taking your time out and presenting this session. It's very important wherein till now we have been learning about the application of 3D printing, how it can be implemented in institutions. It was really a wonderful session, sir. So thank you for sharing with us.
Thank you, Professor Badiga.
Yes. Dear participants, we will be winding up today's day over here. So tomorrow will be the last day for the faculty development program, and the session starts as usual at 10 a.m. So tomorrow after there is a small change in tomorrow's session. The third session for tomorrow will start at 2 p.m., not at 2:30. In the schedule it is mentioned at 2:30, but the actual session will start at 2 p.m. So please adhere to that. You will be getting a mail also from my side for the correction of the timing. So third session will be at 2 p.m. It will be followed by the valedictory and then by the test. Okay, somebody has asked me that what time the test will be tomorrow and for how many marks and duration. Now tomorrow after the valedictory session, the test will start immediately. Marks and duration, it will be given in the Google form itself. It will be provided in the link, so you can just have a look over there. Thank you. We'll wind up the session.